The general form of an absolute value function is y equals a times the absolute value of x minus h plus k. Each of those a, h, and k represents something significant. The a, the number in front of the absolute value, that indicates a stretch or a compression. If that number in front of the absolute value is greater than 1, it's a stretch away from the x-axis. If that number in front of the absolute value is between 0 and 1, that indicates a compression toward the x-axis. The h, that is the x-coordinate of the vertex, while the k is the y-coordinate of the vertex. So when you have an absolute value equation in general form, you can see the coordinates of the vertex. Also, the axis of symmetry, that's the vertical line that goes directly through the vertex. The axis of symmetry would start off as x equals, and then it's the x-coordinate of the vertex. So the axis of symmetry here would be x equals h. Without graphing, what are the vertex and axis of symmetry of the graph of y equals 3 times the absolute value of x minus 2 plus 4? And also, how is the parent function y equals the absolute value of x transformed into this? The vertex has coordinates of hk. So this is x minus 2. The x-coordinate of the vertex here is positive 2. Now you might think it's negative 2, but it's not. If that would show up as x plus 2, remember in the form x minus h, to get a plus 2 there, you'd have to go x minus a negative 2 in order to make that into a plus 2. That's where the x-coordinate of the vertex would be negative 2. If that's showing up as x plus 2, inside the absolute value sign, the x-coordinate of the vertex is positive 2, but that's not the case here. This is x minus 2, x minus h, the x-coordinate of the vertex is h, so the x-coordinate of the vertex here is just 2. The y-coordinate of the vertex is going to be just what it's showing. If that's showing up as a plus 4, that is the y-coordinate of the vertex. If that's showing up as minus 4, then the y-coordinate of the vertex would be negative 4. So in this one, the x-coordinate of the vertex is 2. The y-coordinate of the vertex is 4. So you can see the location of the vertex. It's at 2, 4. Now the axis of symmetry, that's the vertical line that goes directly through the vertex. Once you get the vertex, you can easily get the axis of symmetry. It's just x equals, and then it's the x-coordinate of the vertex. So the axis of symmetry here would be x equals 2. How is the parent function y equals the absolute value of x transformed into this? Well, remember the 3, the 2, and the 4 all do something to that parent function. When you subtract 2 from the value of x, it's going to shift the graph to the right 2 units. So that minus 2, that indicates a shift to the right 2 units. That 3 in front of the absolute value signs, that would stretch the graph away from the x-axis by a factor of 3. And then that plus 4, when you add 4 to the value of y, it's going to shift the graph up 4 units. So the parent function, which is the green graph here, you can see it's narrowed up. It's stretched by a factor of 3. It's shifted to the right 2 units. And it's also shifted up 4 units. So the vertex is 2, 4. Axis of symmetry is x equals 2. It's shifted to the right 2 units, stretched by a factor of 3, and translated 4 units up. What are the vertex and axis of symmetry of y equals negative 2 times the absolute value of x minus 1 minus 3? Also, how is y equals the absolute value of x transformed? You can see the vertex. The vertex is going to have coordinates of 1, negative 3. Remember the x-coordinate of the vertex, when it's in the form of the absolute value of x minus h, the x-coordinate of the vertex is just that number. So if that's a minus sign, the x-coordinate of the vertex is not negative 1, it's positive 1. Remember, general form is the absolute value of x minus h. So that 1 is the x-coordinate of the vertex. The y-coordinate of the vertex is going to be just what it's showing there. The y-coordinate of the vertex is negative 3. So you can see the vertex is located at 1, negative 3. Now the axis of symmetry, that's the easy one. Once you get the vertex, you can easily get the axis of symmetry. The axis of symmetry, it's the vertical line that goes directly through the vertex. It's going to start off as x equals, and then it's the x-coordinate of the vertex. So the axis of symmetry would be x equals 1. Now how is y equals the absolute value of x, the parent function? How is that transformed into this? Well, remember, the negative sign does something, the 2 does something, subtracting 1 from x does something, and subtracting 3 from y does something as well. So when you subtract 1 from the value of x, it's going to shift the parent function to the right 1 unit. That 2 out in front, that stretches the graph away from the x-axis by a factor of 2. This negative sign out in front, when you take the negative of the value of y, it's going to reflect the graph over the x-axis. And then finally, the minus 3, when you subtract 3 from the value of y, it's going to shift the graph down 3 units. So the parent function here, the green graph, you can see to go from green to red, from the parent function to the new graph, you can see it's shifted to the right 2 units. It's reflected over the x-axis. It's stretched or narrowed up by a factor of 2. And it's also shifted or translated down 3 units. What is the equation of the absolute value function for this graph? Well, to get the equation of the absolute value function, remember, general form of an absolute value function is y equals a times the absolute value of x minus h plus k, where h and k, those are the coordinates of the vertex. So to get started here, we're going to locate the vertex. So to locate the vertex, to see where it's at, go to the left 1 and up 4. The coordinates of the vertex would be negative 1, 4. But when you put that in, you have to be careful of your signs. Remember, general form is y equals a times the absolute value of x minus h plus k. H is the x coordinate of the vertex. That's the one you have to be careful on. If the x coordinate of the vertex is negative 1, when you put that in, it's going to be x minus a negative 1. So x minus h, that's x minus a negative 1. It's actually going to be x plus 1 inside the absolute value sign. The y coordinate of the vertex, that k after the absolute value sign, is going to be just what it's showing there. If it's a positive 4, you put a plus 4 after the absolute value sign. If that would have been a negative 4, you put a minus 4 after the absolute value sign. So we have the h and k taken care of. We just have to get the a. Now if you remember, the a, that is the slope of the right branch. So if you look at the right side of that graph, figure out what the slope of that is. You can see it's going down 1 and to the right 3. The slope of the right branch would be negative 1/3. So the slope of the right branch is negative 1/3. That goes out in front. That's a. The x coordinate of the vertex is negative 1. So that'd be x minus negative 1 or x plus 1. And then the y coordinate of the vertex is 4. So it'd be a plus 4 after the absolute value sign. When you substitute those in, it's negative 1/3 times the absolute value of x minus negative 1 plus 4. Simplify that. It'd be negative 1/3 times the absolute value of x plus 1 plus 4. So that's what y equals. Y equals negative 1/3 times the absolute value of x plus 1 plus 4. That is the equation for that graph. Which equation has the graph shown at the right? Well, to get the equation, all you need is the vertex and the slope of the right branch. Because in general form, slope of the right branch, that's the a out in front. The h and k are the coordinates of the vertex. So if you look at this graph, you can see the vertex is right at the origin. The coordinates of the vertex would be at 0, 0. And then the slope of the right branch on the right side, it appears this graph goes down 2 and to the right 1. So rise over run, down 2 and to the right 1, the slope of the right branch would be negative 2. So you're looking for one of these equations that has a negative 2 out in front of the absolute value, and then a vertex of 0, 0. Now with that vertex of 0, 0 is h and k, you really don't need those. It's just going to be y equals negative 2 times the absolute value of x, which is letter D. Which statement about the graph of the function y equals negative 1/3 times the absolute value of x plus 2 minus 5 is true? You can see all of these deal with locating the vertex. Remember, vertex form is y equals a times the absolute value of x minus h plus k. The vertex has coordinates of h and k, but you have to be careful on this because that's showing up as an x plus 2 inside the absolute value sign. If that shows up as x plus 2, in x minus h, to get a plus 2 to show up, it'd have to be x minus a negative 2. So the x coordinate of the vertex is negative 2, and the y coordinate of the vertex is going to be just what it's showing there. The y coordinate of the vertex is negative 5. So you're looking for the answer that says it has a vertex of negative 2, negative 5, and that answer is letter I. The graph of y equals f of x is reflected in the x-axis and translated 3 units to the right, which is the equation of the new graph. So you're looking for the equation that takes this y equals f of x, reflects it in the x-axis, that also means over the x-axis, and translates it 3 units to the right, shifts it 3 units to the right. So if you take that y equals f of x, when you reflect that over the x-axis, if you have a point, you want to reflect it over the x-axis, you're going to take the negative of the value of y. The value of y is this whole right side. So we're taking the negative of f of x. And shifting that to the right 3 units, when you want to shift a graph to the right 3 units, you subtract 3 from the value of x. So we're taking the negative of f of x, and we're also subtracting 3 units from the value of x. So you're looking for the one that says y equals the negative of f of x minus 3. That is letter C.